Wildcats. Today we're looking at Thursday, April 18th, Graphing Polynomials Part 3 on page 74. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at our examples. All right, find the following information for each polynomial and sketch a graph. Example 1, degree name is quintic. Leading coefficient is 2. Number of turns is 5 minus 1, which is 4. It is an odd degree. Now, the y-intercept, what we need to do to find the y-intercept is we need to subtract 8x cubed from both sides. So then that's 2x to the 5th plus 6x to the 4th minus 8x cubed equal to 0. Now that we've done that, we're going to substitute 0 for x. So that's 2 times 0 to the 5th plus 6 times 0 to the 4th minus 8 times 0 cubed, which equals 0. So your y-intercept is 0, 0. Okay. Now at this point, we're going to see if we can factor this. And it looks like we can factor out a 2x cubed from each term, which leaves 1x squared plus 3x minus 4 equal to 0. Okay. So then that's 2x cubed. We can factor this. We know x and x make x squared. Now we need to find all the combinations to make negative 4 and combine to be a positive 3. Okay? So let's try negative 1 times 4 is negative 4. And then negative 1 plus 4 equals 3. So that works. So our factors are x minus 1 and x plus 4. So now let's set 2x cubed equal to 0. Divide both sides by 2. That's x cubed equals 0. Cube root both sides. Well, the cube root of 0 is 0, so x equals 0, but there's 3 of them, so that's multiplicity of 3. Okay, so now let's set x minus 1 equal to 0. So x equals 1, so your 0 is 1 comma 0. And then x plus 4 equal to 0. Subtract 4 from both sides, x equals negative 4, so your 0 is negative 4 comma 0. Okay, so negative 4. Zero, 0 you have, and 1, 0. Okay, now since we know that it's quintic, that's an odd one. We probably want to graph it to see where the end values are. So let's do that. So new document, no, add graph. So 2x to the 5th plus 6x to the 4th minus 8x cubed. So it looks like it's increasing from left to right. So let's have that. Okay. Now it has 4 turns. So there is 1 turn. Now here remember, because it's multiplicity of 3, it has a cubic curve right here. So it's going to go like that. It's a slight hard to see, but it is your cubic right there. And then it turns back up to here. All right. Now, for end behavior, as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches positive infinity. All right, so go ahead and finish up example 1. All right, now let's take a look at example 2. All right, now degree name is quartic. Leading coefficient is -1. Number of turns is 4 minus 1, which equals 3. It is an even degree. Okay, the y-intercept, now to find the y-intercept, we need to add 5x cubed to both sides. So then that's -1x to the 4th plus 5x cubed minus 6x squared equals 0. All right, so once the y-intercept x is 0, so we need to substitute 0 in for each of the x's, so that's -1, 0 to the 4th plus 5 times 0 cubed minus 6 times 0 squared, which equals 0. So we have that at 0. Okay, now we're going to see if we can factor this. So it looks like we can factor out a -1x squared from each term, which leaves x squared minus 5x plus 6 equal to 0. Okay, so let's see if we can factor this. So we know x and x. Now we need to find all the combinations that multiply to give you positive 6 combined to be -5. So 1 times -6 is positive 6. -1 minus 6 is -7. That doesn't work. -2 times -3 is positive 6. -2 minus 3 is -5. So that works. So x minus 2, x minus 3. So -1x squared equals 0. Divide both sides by -1. So x squared equals 0. Take the square root of both sides. Remember, square root is plus or minus. So x equals plus or minus 0, or 0 multiplicity of 2. Okay, now we said x minus 2 equal to 0. So x equals 2. So 2 comma 0. And x minus 3 equal to 0. So x equals 3. So 3 comma 0. Okay, so let's go ahead and put those on the graph. So 0, 2, 3. Now, we know that since it's negative, it's opening downward. Okay. Now, we know it's 0 in multiplicity 2, so it touches and turns. So it touches and turns. And it has a total of 3 turns. So there's your turns. Okay, and behavior as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. Okay, go ahead and finish up example 2. All right, now let's turn the page to the back and look at example 3. As I knock the camera there. All right, example 3. Find the following information for each polynomial in the sketch graph. So the degree name is cubic. Leading coefficient is 6. Number of turns is 3 minus 1, which equals 2. It's an odd degree. The y-intercept is 0. Now, to find that, we're going to substitute 0 in for the x, so that's 6 times 0 cubed plus 11 times 0 squared minus 3 times 0 minus 2, which equals negative 2. So there's your negative 2. All right. Now at this point, we need to find the zeros, and we're going to try to factor. So then that's, looks like we can factor out an x squared, which leaves 6x plus 11. We can factor out a negative 1, which leaves 3x plus 2 equals 0. These are not the same, so it's not factorable. So we need to do p divided by q. And leave space for the synthetic division. Okay, so p is negative 2, and q is 6. So now we need to find the factors of each. So that's plus or minus 1, plus or minus 2. This is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now we need to do p divided by q. So 1 and 2 divided by 1 are just plus or minus 1, plus or minus 2. Now 1 divided by 2 is plus or minus 1 half. And then 2 divided by 2 is just 1, which we already have. 1 divided by 3 is plus or minus 1/3. And then 2 divided by 3 is plus or minus 2/3. And 1 divided by 6 is plus or minus 1/6. And then 2 divided by 6 is 1/3, which we already have. Okay. Now we're going to do synthetic division. And let's go ahead and erase this. And so we have 6, 11, 3, negative 2. Now what we want to do is, instead of starting off guessing all the different factors, let's graph it and find one of them. So I can go to on, new documents, no, add graph. And so we're going to graph 6x cubed plus 11x squared minus 3x minus 2. And it looks like negative 2 is a 0 we can use. So let's do that. Actually, sorry, wrong space. Negative 2 right here. So bring down to 6. Negative 2 times 6 is negative 12. Come on, to be negative 1. Negative 2 times negative 1 is positive 2. And I believe I missed a term. Hold on, 6, 11. That should be a negative 3. That's why, negative 3. So that's a negative 1. Negative 2 times negative 1 is positive 2. Remainder is 0. Okay, so now we have 6x squared minus 1x minus 1 equal to 0. Now, this is not factorable, so we're going to use quadratic formula. So x equals negative 1 is a positive 1 plus or minus the square root of negative 1 squared minus 4 times 6 times negative 1 divided by 2 times 6. We know we should get 2 answers. Okay, so let's plug that into your calculator. So new document, no. Add calculator, not that. Add calculator, control divide. 1 plus control square root, parentheses negative 1 squared. And let me darken the calculator a little bit and adjust the camera lighting. And then minus 4 times 6 times negative 1 divided by 2 times 6. So x equals 1/2. I'm going to highlight, enter, change the plus to a minus, and negative 1/3. Okay. So our zeros, and let's list them right here, are negative 2, 0, 1/2, 0, and negative 1/3, 0. So we know we have a negative 2 here, negative 1/3, and 1/2. Okay, now we know it's cubic and the coefficient is positive, so we know it's increasing from left to right. And it has 2 terms, so 1 and 2. Right, and behavior as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. All right, go ahead and finish up example 3. All right, now let's take a look at example 4. All right, degree name is cubic. Leading coefficient is 1. Number of turns is 3 minus 1, which equals 2. It's an odd degree. The y-intercept is 0. So we need to substitute 0 in for x. So that's 0 cubed plus 0 squared minus 2 times 0 minus 8 equals negative 8. Okay. Now we need to see if this is factorable. So we're going to factor out an x squared from the first 2 terms, which leaves x plus 1. And we're going to factor out a negative 2 from the second 2 terms, which leaves negative 2 times x plus 4. Now, these are not the same, so it's not factorable. Now we need to do the p divided by q and synthetic division. And let's leave space for the synthetic division. So p, q. So p is negative 8. So the factors are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And q is 1, so the factors are plus or minus 1. So now we do p divided by q, which we're just dividing by 1, so it's just plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And again, we want to find one of the zeros first, so we're going to graph this. On new document, no, add graph. So that's x cubed plus x squared minus 2x minus 8. And it looks like we just have 1, and that looks like it's at 2. Okay, so we have 1. I'll actually erase this line. So 1, 1, -2, -8. And we're going to work with 2. So breaking down to 1, 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. -2 and 6 is 4. 2 times 4 is 8. So the remainder is 0. So we know that one of the zeros is 2, 0. Okay, which we can go ahead and put here. Okay, now we have 1x squared plus 3x plus 4, which is not factorable. So now we need to use the quadratic formula. And I think I can steal some space from here to do it. All right, so x equals -3 plus or minus the square root of 3 squared minus 4 times 1 times 4 divided by 2 times 1. So then that's x equals, now the last one we did with the calculator, let's just do this one without a calculator. So x equals -3 plus or minus the square root of, this is 9 minus 16, which is a -7, divided by 2. So we know that the square root of negative number is I. So we have x equals -3 plus or minus the square root of 7i divided by 2. Which means we have two of our zeros are imaginary. And let me show you what the graph looks like when you have an imaginary zero. Okay. So let's come back to our graph. Now I'm going to go to Menu, Window Zoom, and zoom out. Click once, and that should be enough. And you can see here that this is your one of your negative imaginary zero, and this is your positive imaginary zero. Okay, so let's sketch that graph. So looks like it comes up, comes back down, comes back up like that. Okay. All right. So our end behavior is as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. Okay, if you would go ahead and finish up example 4 and start working on your assignment, and have a wonderful Wildcat day.